I'm Theophilus Kofi, and I'm excited to dive into today's content with you. In today's episode, I'm going to explore some fundamental concepts in calculus that will take your understanding to the next level. We'll be focusing on differentiation using the power rule or the sum difference rule. Then we also want to see how best we can, determine points at which a tangent line has a specific slope. You see, this concept might sound a bit daunting at first. Don't worry, I'll guide you through each step, breaking down the concept into easier to follow explanations and providing plenty of examples along the way. Don't forget to hit the like button if you found this content useful and subscribe to the channel for more math and educational. All right. Hello, everyone. Thank you for your time. So today, before we delve into the theorem, I would want us to look at a very important notation that was propounded by one mathematician known as Leibniz. So when y is a function of x, we would also designate the derivative f prime of x as dy dx, which is read the derivative of y with respect to x. Now, let me break it down for you. Now, this dy dx, it just means that the change in y with respect to a change in x, okay? So as y is changing over time, what happens to its respective change in x? So I want us to sort of, take note as we kind of look at the theorem. So the first theorem I want us to be looking at, okay, the power rule for any real number. Let's call it m. Then its derivative, okay, its derivative will just be equal to, let me kind of rewrite this in a different way. So for any real number m, then given y equal x to the power m, then the question is, if I want to find its derivative, what happens? So what happens if there's a change in y with respect to a change in x? Now, this is what the theorem says. The theorem says that, okay, drop the m and multiply it by the decreased power, okay? But it multiply by the function as its power is being decreased by 1. So that is what we are trying to say over here. So let's take note. So we will solve more examples so that we will kind of appreciate it more. So let me give you an example so that you kind of get how could familiarize yourself with it. So if I ask you to find dy dx for the following a part, so we have y equal to x to the power minus 4. Now, so the a part, who can help us to solve it? Per the theorem, we said that drop the power, which is 6, then multiply the result by function being decreased by 1. I mean the power, okay? Then we kind of decrease the power of the function by 1, and that gives us 6 times x to the power 5. Do you all get it? The b, so we drop the power. The power is minus 4. We drop it. Then we reduce the power of the function by 1. So we reduce the power of the function by 1. And that gives us what? Something as this, right? How many of you get this one? Good. So this is what we are going to get. I want us to take note. What about if I give you, let me add another one. Let's call it maybe y equal to, let's say y equal to x. What do you think will be? What will be your dy dx? You can pause your video and try. What to be the derivative of x? All right. Now, so if you assume that x is the power 1, it means that we will drop the 1, okay? Then you multiply it by x. Then you will reduce the power of the x by 1. So you're going to have, and x to the power 0 is 1. So that means you're going to have 1. How many of you get this one? Good, good. All right. So I think that's good for the first theorem that we just explored. Let's look at another important concept that I believe you don't want to miss. What if we have, how do you find the derivative of a constant? So the derivative of a constant, if c is any constant, then it means that its derivative would always be 0. So please, let's take note that derivative of a constant is 0. Okay, so let's take note, please. Let's take note. And another thing that I want us to take note is that derivative of a constant, let's call it c, multiplied by a function, is just going to be the constant times the derivative of the function. So let's take note that the derivative of a constant times a function is just going to be the constant times the derivative of the function. So please, let's take note. Very, very important. So let's solve some examples and let's see how best we can, test our knowledge on the theorems. So how do you find the derivative of the following? So find dy dx. the following. So we have y equal to 7 times x to the power 4 is that. So the dy dx would just be equal to what? We said that the derivative of a function of a constant times a function is just going to be what? The constant times the derivative, right? That's what we said. Okay. So which means that now what's the derivative of x to the power 4? So we said that we drop the 4, then we multiply the result by the x as we decrease its power, right? And that should give us 28 x to the power 3. Good. So let's take note. What about the b part? We have y equal to 1 out of 5 to the power 2. So what to be the dy dx? So our dy dx will just be what? The constant times the derivative of the main function. Okay. And with this, we're going to have, so derivative x to the power minus 2 will just be minus 2. Then we decrease the power of the function by 1. Okay. So we decrease the power of the function by 1. And that gives us what? Minus 10x to the power minus 3. And this can be written as this. I hope you all get it. Okay, good. That's very important. So it's important that we understand, problems even as we explore it further. So the differential of a constant function is just a constant times the derivative of the function, right? So this will give us what? So we drop the power, then we decrease the power of the function by 1. Okay, and that gives us something as this. Okay, so all right, so this question, you may want to pause your video, try and see if you'll be able to solve it. All right, okay, so what we do is that the easiest way to solve this problem is for us to try to invert the x to the power 2. Okay, so let's write it as something as this. Okay, all right. Now, over here, we said that the derivative of a constant function is just a constant times the derivative of the function. Okay, so with this, when we find the derivative of x to the power 2, we said that you drop then we decrease the power by 1, okay, minus 3, and that gives us minus 2 on 5, x to the power minus 3. But this can equal be written as what? Minus 2 on 5, then we have something like this, okay? So let's take note. I think I can give you a lot of examples to explore, but at this point, I also want us to look at another theorem that I believe is so important. And with that theorem, we said that the derivative of a sum is a sum of the derivative, okay? So the derivative of a sum is a sum of the derivative. So let's take note. So given two functions f and g, so we claim that the derivative of the sum of two functions is a sum of the derivative. So let's take note. This is a very important concept you don't want to miss. So the same applies to the difference. So with the difference is the same principle. So let's take note. So we'll solve more examples so that you kind of rules. So let's take note. So how do we find such functions? Find a dy dx of 5 or the function 5x cubed minus 7, and then the b part we have dy dx of 24x minus root of x plus 5 on x. Okay, how do you find such functions? So for the first part, we said that the derivative of the difference of two functions is the difference of the derivatives. Okay, good. That's very good. So we claim that such a problem can be solved by using the difference theorem. Okay, so we said that this can be employed by using this theorem. Okay, so with that, we're going to have, so the derivative of this, we said that we multiply the function, the constant by the derivative of the function. Okay, and that gives us what? So that will give us 5. Like this is to the power 3, not this is to the power 3. So let's take note. So that gives us what? 3x to the power 2 minus what? And we said that derivative of 0 is what? The derivative of 0 is what? Is 0. So let's take note. The derivative of the constant is what? Is 0. So let's take note. All right. So how do we find the derivative of the function? So over here, we employ the theorem of the sum and the difference of derivatives, right? So that's exactly what we are going to employ here. So with that, we're going to have, okay, so this is how we are going to do the distribution. Now, what's the derivative of 24x? And that gives us what? 24, right? This is a radical function, right? Now let's do some algebra here. So root of x can also be written as what? X to the power, right? Now, how do you differentiate? So it means that this is the same as what? X to the power half, right? So how do you differentiate x to the power half? So we said that drop the power, okay? So we drop the power, which means you drop the half, then we decrease the power by 1, and that gives us what? Minus half, okay? Good. What about 5 divided by x? So the easiest way to solve this one, by inverting the x, we're going to have 5 multiplying x to the power minus 1, okay? So this place you see it as what? 5 multiplying minus 1. Okay. In that case, you're going to have, so by dropping the minus 1, you're going to have minus 5. Then we decrease the power by 1, and that is minus 2. Okay. With that, we're going to have 24 minus half. Now, by inverting it back, you're going to have something like this. Okay? So you're going to have 5x to the power 2. Okay. But this further be written as what? Minus 5 to the power. If you have any questions, just your question in the comment section and I'll attend to you guys. Now, let's look at, I believe it's a very interesting problem that we have to tackle. So that is an example that I want you guys to solve, and let's see what we'll get. So if I give you now differentiate y equal to 3x5 plus 2 cube root of x plus, now how do we solve this? Now by derivative, you're going to have dy dx equals, okay? All right. So now over here, we said that the derivative of the sum is the sum of the derivative, okay? All right. So in that case, we're going to have the derivative of this function plus the derivative of this function, the derivative of this particular function plus the derivative of such function. Okay, good. Now, what is the derivative of x to the power 5? So we said that we drop the power, then decrease the power by 1. Okay, so in that case, we're going to have what? 3 multiplying 5 x to the power of 4. Okay, with this one, remember that this can be written as what? X to the power of 1/3. Okay, remember we have, what did we say? We drop the power. So that gives us what? Then we decrease the power by 1. So by decreasing the power by 1, what do we get? Anybody? And that should give us what? 2 to the power 3. Good. And this, we can also simplify this as what? X to the power 3, x to the power minus 2. Okay. And we said that what? We do what? We decrease the power by 1. We drop the power. Okay. And that gives us what? If I drop the power, that gives me minus 2. Then we what? We decrease the power by 1, and that gives us what? Minus 3. What about this one? When you derivative of root of 5, we said that since root of 5 is a constant, then the derivative of a constant, we said is 0. Very good. So in that case, you should have what? 15x to the power 4 plus 2/3 of x to the power minus 2 on 3, x to the power minus 3, right? But this can further be written as what? We can further simplify this as well. So this is the result of the problem. Okay, this is the final result of the problem. I believe we get it, right? Okay, so at this point, would also want us to look at another interesting point that we don't want to miss. So I want us to look at a very interesting question, which is find the points on the graph of the function minus x to the power cube plus x to the power 2 at which the tangent line is horizontal. Okay, at which the tangent line is horizontal. So I want us to take note. Now, at this point, I want us to recall that the derivative of the slope of the tangent line to x. At this point, I want us to look at this very interesting problem, and that one is the points on the graph of the function minus x to the power cube plus x to the power 2 at which the tangent line is horizontal. Okay, but I want you to recall that the derivative is the slope of the tangent line to x. Take note. Let me say that again. The derivative is the slope of the tangent line to a curve. Now, when we look at the problem, it says that so if the tangent line is horizontal, it just means that its slope will be 0. If the tangent line is horizontal, it just means that the slope of the horizontal line will just be 0. So therefore, we just wish to find all the points on the graph of f where the derivative of f equals 0. Is that okay? So let's look at that. So if you have the function f of x to the power minus x power 3 plus 6x. Now, what we need to do is that since we said that the slope of the tangent line is 0, we first have to find the derivative of this. Okay, then set to 0. Okay, this will help us find the points. Okay, so let's find the first derivative of this function. So this derivative will just be as what? So we drop the power and decrease the power by 1, and that gives us what? 2. Over here, we also drop the power, okay? And that gives us what? We drop the power, then we decrease the power by 1, and that will give us something like this. So in which case, we're going to have, is that okay? Good. Now, remember that the tangent line is horizontal. So if the tangent line is horizontal, it just means that we just have to set this derivative to 0, okay? So we need to set to certain f prime of x to 0, okay? So this implies that minus 3x squared plus 12x should be equal to 0, okay? So when you factor out minus 3x you should have x minus 4 equal to 0. Okay, so minus 3x should be equal to 0, and okay, x minus 4 should be 0. In that case, you have x equal to 0 or x equal to 4. Okay, very good. So let's take note. All right, I want us to know. Remember, we want to find a point on the line, on the curve, of which the tangent line to the curve is horizontal, right? Good. Now, it just means you need to find its corresponding y values for the x values, okay? So it just means that we have to substitute back into the main function, and that would be able to find it, right? Good. Remember that the main function is minus x to the power 3 plus or 6x squared, right? Since we already know the x values, we just have to plug it back, as I said, into the main function, in which case you can have something, and that gives us what? That should give us 0, right? And then we plug in this, the second x value, which is 4. So in that case, you can have something as this, and that should give us what? 32, right? Good. So the tangent line just means that the tangent line to the graph of f of x is horizontal at the point. So the first point will be what? 0, 0. And so the points will be 0, 0, and then what? 4, 32. 32. Is that okay? Good. I believe we all get it. Okay. That is very good. That's very good. All right. So what if I give you a problem to solve? And the problem is, so there's a problem. So when I find a point on a graph of the same function we solved earlier on, at which the tangent line has slope 6. Now this one, the slope is 6, not 0. So it just means that the strategy we employed in the previous example would be considered here. Except now we are now concerned where the derivative equals 6. So I just want us to sort of, take note. And remember that given f of x as this, we claim that its derivative will just be what? This, right? Good. Now, since the slope is 6, it just means that, remember, this is also the slope. Okay, it just means that this, we have to set this to equal to 6. So please take note. So this should be set to 6. All right. So when that is done, we can just bring the everything on the left so that we can just solve the problem. The easiest way for us to solve this, somebody may say just divide through by -3, and that would make the work easier, right? And that's one of the wisest decisions you can ever make, which is by dividing through by -3, and that should give us this. Now over here, somebody may say, let me use this a quadratic equation, right? Which means you can employ the quadratic formula, right? And remember, with the quadratic formula, we said that the quadratic formula is what? If you recall, this will be your quadratic formula, right? Good. Now, by using the quadratic formula, we should get something as this, which should give us, when we further simplify, half plus 4 plus or minus root of what? That should be 16 minus 8, all divided by 2. And that should further give us what? If you have already done, that should further give us 4 plus or minus root of 8, all divided by 2, right? Which means that over here, when you kind of simplify it a bit, you should get plus or minus root of 2 all divided by 2. And when you simplify this a bit, you should get something like what? And that should give us what? 2 root 2 plus or minus root of 2, right? Plus or minus root 2. So please, let's take note. Now that we have this, we have to find the corresponding y values, just like the way we did for the other part, right? So we have to find the corresponding y values. And so the first y value will be the case when we plug in either the plus or the minus of this value that we get. So we 2 plus root of 2, plug into the main function, we should have what? 2 plus root of 2 raised to the power 3 plus 6 multiplying the whole of this value. And that should, if you use a calculator, that should give us what? That should be 16 plus 10 to the power 2. Similarly, f of 2 minus root of 2 should be what? 16 minus root of 2. Okay, so it means that the tangent line to the function has a slope of 6 at the points. So it has slope at the point. So now we need to bring the points together. At the point 2 plus root of 2, and then 16 plus 10 root of 2, and then what? 2 minus root of 2, okay? And then 16 minus 10 root of 2. So please, let's take note, okay? Let's take note. These examples are very good. It's just to help you to challenge how you think. Probably you might have understood the concept. So I want us to kind of take note of that. So today, we've been able to kind of know certain theorems, and we said that for the power rule for differential equations, what happened is that as long as m is any constant, we drop the m, then we decrease the pi by 1. And we also said that the derivative of a constant is of a constant is 0. Okay. And we also claim that the derivative of the sum or the difference is the sum of the difference of the derivative of the terms. Okay. So I want us to take note. At this point, please subscribe, like my videos, or put in the notifications button and put on any comments, and I would attend to all of that. Thank you so much. And also spread the news by sharing the videos to your friends, your colleagues, your loved ones. Okay. Thank you so